Yes, Ayaan?
We did the sublimation number 3.
Yeah, sublimation, right? Okay. Now over here, we will use one example of it. Okay. So over here, see, when camphor or the ammonium chloride is heated in the china dish covered by a inverted funnel with cotton plug overhead, the vapor of ammonium chloride are converted into sodium ammonium chloride or coming in contact with the cold inner wall funnel. So this is what basically the sublimation of ammonium chloride it is. Okay, this is the example you can see. Now in the previous class, we did about the changing in temperature, like the boiling point, the melting point and all that, right? Now we will do something else, which is the effect of change of pressure. Okay. So over here, if we compress a gas in a cylinder, the distance between the particle of a gas is reduced. For example, this is the container. Over here, the gases are, the particles are like this. But if you will reduce the size, then the particle will be closely packed, right? So this is what.
Yeah.
So what happened? Change in pressure means like if we compress something, then over here, how can they will come together and plus their temperature will be lower, right? And now how we can do this? By applying high pressure, the particles of gas can be brought close together, first thing. Then solid carbon dioxide, which is the dry ice, is changed into carbon dioxide gas directly without changing into liquid when pressure is reduced to 1 atmospheric pressure. Okay. Then the state of matter, solid, liquid, gas are determined by the temperature and pressure. Okay. So what you will do, you will write effect of change in pressure, the heading, and then you will write these 2 points. Clear? And then you will draw this. Over here, what is happening? This liquid. You can convert this liquid into gas with the help of evaporation. And after that, other thing, what you will be doing? Just a minute. Okay. Now, other thing is that from this gas and solid, if you are going to convert this gas into solid, sublimation, solid into gas, sublimation, solid into liquid, melting, liquid into freezing, solid, freezing. Clear? Okay. Ayaan, am I audible?
Yes, yes.
Okay. So now you will just put B, effect of change in pressure. Just put a heading from here. After that, you will write these 2 points, only 2 points, and then you will draw this diagram. Okay. Give the heading B, effect of change of pressure.
Okay. I'll start from effect of change of pressure.
You have to just write B, effect of change of pressure, right? And after that, you don't have to write anything. You have to write only these 2 points.
There is no A. I will just write it as A.
Sorry?
We will. I will
And
just
you
write
are
B.
not audible to me.
I will write B or A.
Yeah, B.
A. Okay.
A you have already written. You will just write B and write this effect of change of pressure.
No, teacher, I have not done anything.
You wrote it? Oh. Now just write these 2 points.
No, I didn't write. I didn't write.
You didn't write? Okay.
And you didn't give me anything like A.
Ayaan, I can hear you. I don't know why.
Hello.
I can hear you, but your voice is too low. I don't know what's wrong with my laptop. Just speak it now.
And it is showing my voice is coming properly.
Mm-hmm.
Maybe you have to refresh. Now your voice is not coming. Your voice is not coming. Okay. Yes, ma'am. Oh,
Can you hear me now?
yes,
I
yes. Yes, ma'am. Your
Yes.
voice is coming.
Okay, okay, great. Okay, so let's just start. Okay. Hmm. Okay. You can see the screen.
Yeah.
Okay, so you can start. Okay. You have written this B effect of change of pressure.
No. Teacher,
Okay,
is
just
there
write
any
it.
A? Is there any A?
Yeah, is there an A? In the previous class we did the A by changing temperature.
A.
You didn't wrote that? No?
Mm,
See, after this, after the
yeah. Yeah.
gaseous
Yeah.
state, after this change in physical state, the first one is change in temperature. So in the change in temperature, we did melting point, we did boiling
Okay.
point, we did sublimation, right?
1 second. Okay. Done. Done.
Okay. Now B part, write it down the heading.
Done, ma'am.
Now write these 2 points.
Okay.
Okay.
Ma'am, done. Ma'am, done.
Okay, Ayan, can you see the screen? Actually, I think I was facing some issues. Now I fixed it. Clear?
Yeah, yeah.
Screen.
You're
Oh,
lagging a lot.
is it still the same?
A little laggy.
Okay. I've just fixed it. I hope that will be fine after 2 minutes.
No, your mic is cracking a little. Your voice, not
Hmm.
mic.
Okay, can you hear me now? Is it okay?
It sounds a bit louder and a little
Is it
muffled.
okay now?
Yeah, now it's better.
Oh.
Sure, now I will write the third point, thus state of matter.
No need to write the third point. Just make this diagram.
Oh,
Done.
No, almost.
Okay, okay, do it, do it.
Hello, teacher.
Yes, done. Okay.
You see in that bottom part of the table,
Which
it
one?
is showing gas in the of the table. It is showing gas to solid is sublimation.
Yes.
That's wrong, right?
Over here, there, see, you have two types of book. One where they are mentioning the
Deposition.
sublimation. Yeah, yeah. Over there is a thing, but solid to it, when you will be doing that, it's basically the deposition, and in somewhere is a different type of sublimation. Right? So you can just
So,
put a slash and then you can write deposition as well. Okay?
what
Because
did
in
you say,
some
teacher?
books,
Your voice is
uh,
cracking again.
okay, so I was saying that you can put a slash and you can put a deposition as well. In some books, it is written both sublimation, right? Sublimation in
Okay.
other way it is basically just put a slash and write deposition. Okay.
Okay. Okay. Okay, done.
Okay. Now coming to the next one. It is first what is evaporation? Okay. So it's nothing a surface phenomena in which liquid changes into vapor at any temperature below its boiling point is called evaporation. Okay, so over here, liquid is changing into vapor, but remember one thing, it should be below the boiling point.
Your voice
What
is
happened?
cracking a lot.
Why it is so? Just a minute. Ayaan, can you hear me now?
Yeah, but still cracking.
It's
See,
breaking.
now from your mic, I can hear my own voice. Just really laggy.
Why it is so? I think Ayaan, do one thing. Can you please rejoin once again?
Okay,
Leave the meeting and rejoin. In case if the problem doesn't solve, then I will rejoin. Let's see what's happening. Okay.
okay, okay. Yes, ma'am. I'm back.
Yeah. And can you hear me now?
Yeah,
It's better.
but yeah, it's okay.
Still the
Still,
problem is there.
see, now it just cracked.
Okay. Okay. So let's just
Some see again, it's cracking.
okay. In case if your voice didn't come to me or anything happened, just let me know. Okay.
Okay.
Now evaporation. So a surface phenomena in which liquid changes into vapor. At the remember one thing, it should be the below the boiling point. Okay. And over
Okay.
here, particles on the surface of a liquid have higher kinetic energy than other. So they break the force of attraction between the particles and escape from the surface of liquid into the form of vapor. Now, what is this kinetic energy? So kinetic energy is basically that will be keep on moving. That is because of that energy, you are moving from one place to another, right? So the particles on the surface of a liquid, they have very higher kinetic energy. So higher the kinetic energy, more the speed, right? So automatically, quickly, they changes into gas form. Okay.
Yeah.
So because this is
Yeah.
basically the evaporation. Now, there are some factors that affect the rate of evaporation. So see, first of all, exposed surface area. For example, this is a t-shirt, okay, that you have to dry it up, right? So this t-shirt, if you will spread it, then it will take less time to change that, like from that it has a liquid particles over there. Those liquid particles will turn into vapors. If you will spread it, you will take more area, more easily it will evaporate. But if you will put it in a small area, then it will take a longer time, right? So surface area means if you will increase the area of liquid, the rate of evaporation will increase. If you will decrease, then rate of evaporation will also decrease. Clear? Okay.
Yeah.
Now, increase in temperature. So, for example, there's a sunny day and there is a rainy day. In which day your clothes will be drying up earlier?
On the
Sunny, hot day,
windy
right?
day,
So, over here,
a hot day.
increase kinetic energy of particles, hence the rate of this. So, what happened when you increase the temperature? The speed of kinetic energy, the kinetic energy also increase. And I already told you, when kinetic energy increases, the speed of particle increases, right? So what is the relation? If you will increase the temperature, kinetic energy will increase. And when kinetic energy is increasing, automatically the speed of particles will increase and they will quickly convert from liquid to gas form. Clear?
Yeah.
Then humidity. When the humidity of air, degree of dampness of air, you can say humidity, it's like little bit mixture, moisture and all that, is low. Evaporation rate is increased. Very, very, very important. So humidity should be low. Then the rate of evaporation will be high. right? For example, if humidity is high, so there is lot of stickiness around you. That means lot of liquid is present, right? So more the liquid, less is there. The quantity of humidity is less, more will be the evaporation, and more humidity will be the less evaporation. Clear?
Yeah.
And then wind. When wind speed increases, rate of evaporation also increases. So you know, for example, you have put it your clothes to dry it up. There is a windy day. It's a windy day. Air is like it's wind is going on, blowing everywhere. So automatically within 10 to 15 minutes, your clothes will dry up, right? But for example, there is no wind, nothing. So it will take a longer time, right? I'm not comparing it with sunny day and the winter day. I'm just saying if in case there is a wind, then there are chances that your clothes will be drying up earlier as compared to the situation where there is no wind. Okay.
Yeah.
So you will write evaporation, then you will write all this. Okay.
I will write the definition of
Yeah.
evaporation.
Evaporation, the definition till here. And then the factors affecting evaporation or the factors affecting the rate of evaporation depends on. Okay. Slash rate of evaporation depends on A, B, C, D. Okay.
Yeah. Done, ma'am.
Okay. Now, evaporation always causes cooling. Okay. So over here, what is happening? Evaporation is always causing cooling. So you're like, ma'am, how can this be possible? Okay. So the cooling caused by evaporation is based on the fact that when a liquid evaporates, it takes a latent heat of vaporization. So whatever energy is required, it is taking along with it, right? And automatically what is happening? The surrounding, it becomes cooler because all the heat is going along with this. If it is liquid is turning into gaseous form, all the heat is going with the gaseous form, the vapors, and rest is your this. So that's why it is evaporation. So remember, vaporization not, it's evaporation leads to cooling, not vaporization. Clear? Yes.
Yes.
Now, there are some examples. When we put acetone on our hand, it gets vaporized by taking heat from our hand and our feet. So over here also we feel cool when we put acetone, like the thinners and all that in our hands. Then we should wear cotton clothes at summer to keep cool and comfortable, as cotton is a good absorber of water. So it absorbs the sweat from our body and expose it to the air for evaporation of sweat, thus cools our body. So over here, whenever we wear cotton clothes, we feel like that, okay, we are not feeling hot because whatever heat or the sweat is there, like the cotton is absorbing it and our body is feeling relaxed and our body is feeling cool. That's why we always, it is suggested that in summer season, because we sweat more in summer season, wear the cotton clothes. Then often people sprinkle water on the ground during summer. This water takes heat from the ground and surrounding air above it, thus making the place cool. So for example, in especially rural areas, where for example, they are sleeping on the floor, right? So what they will do, they will sprinkle the water over there. Why? Because if the entire day it is hot, so what is happening? The land is absorbing all the heat. But when they will put a sprinkle water over there, what will happen? Of course, when they will put the water, it will evaporate, right? So along with the evaporation, the heat of the ground, they will take it, right? And automatically the ground where they will have to sleep or they are planning to sleep, that will be the cooler space. Clear?
Yeah.
Okay. So now you will quickly write down evaporation always lead to this, then examples. Okay.
Done, ma'am.
Ayan, you were saying something?
Yeah, done.
Done? Okay.
And now I will write
You wrote the,
this
sorry,
both. I'll write both of them.
you wrote this?
Yeah, I did.
Okay. Then you have to write second and third. You have written?
No.
No? Okay, yeah. Second and third, you have to write that. Okay.
Okay. Done, ma'am.
Okay, done.